Good morning. Okay. Picking back up here, I figured out what I have to do. And it is something obvious. Alright, so for now, I want to get rid of that. I will need that slide. I was on the right track, but I'm missing some terms. So I'm going to get rid of that. I can't believe I forgot this. There are two things you're always allowed to do in mathematics. You can always add 0, and you can always multiply by 1. So I'm going to do two things. I'm going to reorder my terms. I'm also going to add in the terms I need. In this case, I'm adding in that XU alpha for the first component. Now I've added 0. XU alpha minus XU alpha is 0. So I haven't changed anything. Then it was minus YV alpha minus ZW alpha. In the Y component, I'm going to add YV beta. Where my terms minus X mu beta minus YV beta Z W beta. There's the new Y component. What I highlighted are the terms that were inserted. And again, in each case, I just added 0 to the component, so I didn't change anything. That is a legal step. Now I can continue. Break this into two separate vectors. One vector, you take all the positives. Second vector, you're taking all those negatives. Wrong line. It's yu beta plus zu gamma. Right? Yeah. Comma. Alpha, beta, gamma. Beta plus ZW. There's the first vector. Minus, now take all of those negative components. CW. Then X u gamma plus look in that first vector. Really? Are you gonna stop messing with me now? First component can factor out a u. Second component, we can factor out a v. Bless you. Third component, factor out a w. Second vector. Alpha factors out of the first component. A beta is going to factor out of the second. And a gamma factors out of that third. First vector, Scalar multiple. Right, each of the three components has the same scalar, x alpha plus y beta plus z gamma, factor it out. We're then left with u VW. Second vector is also a scalar multiple, xu plus yv plus zw. That's with alpha, beta, gamma. X alpha plus y beta plus z gamma. Isn't it that dot product? Then the xu plus yv plus zw is also a dot product. XYZ was what vector? What about alpha, beta, gamma? And what was UVW? Which is what we were originally trying to get. How many other proofs did we do yesterday?
How did you know when to ask?
You want the truth, or do you want what I would tell people to sound impressive?
You can tell me about.
It's obvious. Truthfully, I worked backwards. I started with the right-hand side, and I didn't get too far before I realized what I had to do, because I found that I saw those terms and said, oh, yep, okay, I'm good. I know what I have to do now. But of course, you never tell anyone that. You just go, well, it was obvious. How many proofs did we do last class? Was it 4? That was question 2? Yeah, I think it was 2, right? This was the third one. I got stuck on. The first one, I think, if I remember correctly, was 2 ways to do it, right? The easy way and the hard way. So that hard way and then these other 2 proofs are algebraic proofs. It's what we call algebraic proofs. There was really no logic involved. It was all just manipulation, right, in algebra. That first method of question 1 is more of a typical logical proof using theorems, using already proven facts. And so far we haven't really done too many logical proofs. It's all been algebraic. That will change in linear algebra. Even the video, the lecture videos, I don't know how many logical proofs there were. I think they're mostly algebraic so far. And so this is the last question we had. Determine a unit vector perpendicular to the plane that contains the two vectors A and B. There's an arbitrary plane, let's say. It contains two vectors. It's going to draw two arbitrary vectors. Call them A and B, or A and B, rather. I'm also going to draw an arbitrary vector n. And what we know about n is that it is perpendicular to the plane. Then what do we know about the relationship between n, A, and B?
And it's cross product by A.
I'm not there yet. If n is perpendicular to the plane,
Perpendicular to both of those.
it would have to be perpendicular to A and perpendicular to B, right? And a vector perpendicular to two vectors is the cross product. That's how we're going to find this vector. Now, of course, they want a unit vector, so once we find the vector, we'll normalize it. So let's just call the perpendicular vector n. Does it matter if I do A cross B or B cross A to find n? No, right? The only thing that's going to change is whether it's opposite direction. So that doesn't matter. What's A cross B? So what's the first component of A cross B? Do it component by component.
Negative three.
You write ijk and then 2, -6, -3, and then an extra 4, 3, -1 for the
That's how you calculate it. You're setting up the term. Now, once you do all that,
right.
I want what the first component actually is.
I got 6 minus 9 times I for the first one by doing the
Check your sign.
is it 15?
It's 15.
Ah.
Should be 6 minus -9. Right, it's negative. You should wind up with -3 times +3,
Yeah.
and then minus that.
Okay.
What is your second component?
10.
That's what I got. +10. No, I didn't get +10.
I got -14.
It should be -10. Second component gets multiplied by a minus when you do the determinant. And then what is the final component? How are you getting it?
Oh, 24, 18, or 19.
So you're right. 2 times 3 is 6. 4 times -6. It's 30. And 6 minus -24. Can't we factor a scalar out? So we should make that look like a 5.
Why is it not like a positive 10?
Because when you do the determinant, right, so you get -2 minus -12, right?
Yeah.
Which is 10. But the second component always gets multiplied by -1 in the determinant. As for why it's a -1, you have to study cofactor expansion in linear algebra. Right, so like I said, for now, you just have to take my word for it. Or what I do is I flip the order. Right, so instead of saying a -2 minus -12, I'd say it is -12 plus 2, -12 minus -2. What would happen No, I think I can probably do this, right? If I just get rid of that 5,
It's still perpendicular, the magnitude change.
doesn't change the direction, does it? Which means it would still be normal. It would still be perpendicular. Right, so I'm not going to say equals because obviously it's not going to be equals, but I'm transforming it. So I'm going to use this vector instead as my normal vector. Is it unit? Which means now we have to make it unit. How do we do that?
By the magnitude,
So again, be careful with the terminology.
divide each term by the magnitude.
Right, multiply the vector by the reciprocal of the magnitude. Right, so it would be this, right? En 1 over magnitude of n times n. What is the magnitude of that vector?
So,
What was it? And there's the magnitude, or there's the unit vector perpendicular to the plane. Two acceptable answers. That answer or the negative of it. Right, it just depends on how you did the cross product, A cross B or B cross A. Even if you left that 5, so you use the 15, negative 10, 30. When you normalize it, you're still going to get the same vector. The magnitude should be 5/7. I'm sorry, not 5/7. 5 times 7, 35. What the magnitude should be. And then obviously when you then multiply that original vector by 1 over 35, you'll get the exact same thing. Now, what if instead of a unit vector, I just asked you for a vector perpendicular? How many solutions could you have?
Infinite.
Infinitely many. What are they?
Any scalar multiplier of that vector.
Yep. Any scalar multiple of the 3, negative 2, 6. Positive or negative. Right? They'd all have the exact same direction, right? Just different magnitudes. So just keep that in mind if you're checking. Now you're doing a problem like this in the book and you check the answer and it's different than yours. See if it's different by a scalar multiple. Questions on the cross product? If I remember correctly, I think next week we start analytic geometry. We start actually looking at objects in space with lines and planes. And we also will look at surfaces and 2 new coordinate systems. Also next week is the first quiz. That's exciting. His first homework was due today. And it was due before class. Second homework is due Thursday. Third homework due next Friday. And continue looking at the project.
What is the district?
What is it?
The district thing. The description.
The first discussion?
Second one.
That hasn't even posted yet.
For some reason, it's
It may be available, or not quote unquote available. You may be able to actually see it in one of the modules, but it's still locked. So you can't access it. I think the second discussion is week 4. Yeah, I didn't do it on the quiz week. Yeah, so it's week 4. So it's probably showing up in the gradebook, and I hate how Canvas does that. It's not available yet, but it's still going to be in the gradebook. So don't worry about that just yet. Still got a couple weeks. I'll leave the rest of today for you. If you want to work on the homework, maybe work on the project. So I think you can do the project now. I don't think it requires anything else. It may. I'm not 100% sure. Or if you just want to leave because it's Friday and it's weekend, be my guest.